Hi there. So in this video, let's talk about just as a kind of basic on one-to-one function, one-to-one functions, inverse functions. What all these things actually? What does this means? So in fact, in this, if you look at the book, I mean, you have the book or you have this. I think in the book it is given. Can you see the picture? I need another light. This picture. Okay, so in this picture, if you look, in this picture, if you look, this is actually when every element in the x is linked with some element in the y, then this is actually one-to-one function. When two element in the x, see this is x1 and x2 linked with y1, when the function is like this, then it is not one-to-one. And when from one element in the x gives two different answers, then it is even not a function. So to be one-to-one, it has to be like this. This is not one-to-one. This is not even function. So this is the point. And for example, if you look at the data, can you see this? This is actually one-to-one function graph. This is not one-to-one because two different thing actually have one range. This is actually domain, this is the range, this is domain, this is the range. And in this picture, this is the domain, this is the range. Y value is always the range, x value is always the domain. So this is one thing from here, and this is called horizontal line test. Can you see this? This is called horizontal line test. So suppose if some function is given, then you will draw a horizontal line. If it cuts at two different points, then this is not a one-to-one function. One-to-one function will not cross the horizontal line at two different points. Let me, there is some example here. See this one. You see this picture. No matter how many lines you draw, everywhere the graph is actually touching at one point only. See, this is only one point. But here, this horizontal line actually crossed the graph at two different points. See this one and this one. That's why it is not one-to-one function. This is one-to-one function. Alright, then how to find the inverse? There is a couple of examples given here. To find the, you can just look at this picture also. To find the inverse, basically the domain will go to the range and range will come to the domain to get the inverse. For example, this one, see this example, if you can see this example, see -3, -27, so this is the sum example. These functions, this is some data sets, and the x value is this, y value is this, x value is this. So this is given -3, -27. This one's inverse will be -27, -3. This value will come first, this value will go later. This will come first. See, -27, -3, -8, -2. 8 was second here. In this, 8 is first. -2 was first here. In the inverse, it will be second. So basically, all the thing will change their position. Y will become x, x will become y for the inverse. And always, if you draw a line, see this. Or if you draw a line for this point, inverse is this point, because if it is AB, this will be BA. Okay. Suppose if some point is, let me show you this. Suppose if you have a graph, suppose this is x-axis, this is x-axis, this is y-axis. Let's say 1, 2, 3, 4. 1, 2, 3, 4. Now suppose we have a point 2, 3. So this is, let's say, we can say some other value also. Let's say 1, 4. Okay, so 1, 4, 1, 4. So 1 is here, 4 is here. 1, 2, 3, 4. So this is the point. Okay, so what will be the inverse of this point? Inverse of this point will be simply 4, 1. This point's inverse is 4, 1. Okay, so 4, 1 is where? 4, 1 is here. Let me plot inverse. So this is 1, 2, 3, 4, and this is the 1. So 4, 1 is here. Okay, so this point's inverse is this, and this point's inverse is also, we can say it. See, This point's inverse is also this. This is 4 1, so this is 1 4. That means for this point inverse is this. Again, for this point inverse is this. They are inverse of each other. Okay, and if we draw a line, actually if we draw a line y equal to x line, this is our y equals to x line. Tada, it will go through the origin. Oh my god, it looks like a bit. Okay, always these 2 points will be same distance away from this y equals to x line. This is our line, so these 2 points will be same distance away. This point's inverse is this. Now suppose if you have some other points here, so that this point's inverse will be here, same distance away from this y line. Now let's extend the idea. Suppose now we do not have the point. Suppose we do not have the points. Suppose we have some graph, something like this, something like this. So what will be the inverse? The same graph will go up. Same graph. Let me make it some. Let's not make too much thing. So the inverse. Suppose this is line given. Now question is, what is the inverse of this graph? Okay. This is not graph. This is just y equal to x line. This is not the graph. This is our graph. So this line's inverse will be like this. Same distance it will go up, then again it will be straight like this kind of. Okay, so this is the graph. So this is the graph. Let's say this is the graph 1, and this is the inverse of that graph. This is the inverse of that graph. This is the inverse. Graph 2 is the inverse. They are inverse of each other. Okay, this is how we find the inverse of the graph. And for the function, suppose if somebody tells you to find out the inverse of some function, then x and y will interchange, and we have to solve that in terms of x and y, whatever is needed. So that's that way we actually solve it. There's a question here. And there's a lot of question here. What do you want? I think I can solve one question so that you can see how the inverse thing works. How to find if the equation is given, how to find the inverse. For example, let's say I have some function given. This is some random math. I'm just making it now. F(x) equals to, let's say, 3x minus 1 divided by x plus 1. This is a function. The question is how to find the inverse of this. Okay, so to find the inverse, first of all we have to write it y equals to this is always like this, then x plus 1. Now you can do one thing. You can directly change x and y, or you can do it at the end also. Both is fine. So what do you want? Okay, we will just do it at the end. Okay, x and y we have to interchange, because as you know, x and y will interchange for the inverse. So if I do it, this is y equal to, we have to find x equals to what? So it will be x y plus y equals to 3x. I'm just doing some cross multiplication. This into this equals to this, and this is remaining there. Then xy minus 3x, I'm just bringing it here, equals to minus 1 minus y. Now we can take x common from here, so it will become y minus 3 equals to minus 1 minus y. So these are all you can write here, or then we can write this like something like x equals to minus 1 minus y divided by y minus 3. Okay, so it looks kind of odd, so we will just multiply up and down by a minus 2, because this looks, there are both is negative. This is a simple calculation. I'm just close to the answer, so I will use another color. So if I multiply both up and down by a minus sign, it will become 1 plus y, and it will become 3 minus y. This is not necessary, but just to make it look good, I'm just multiplying both sides by this. Now we actually very close to the answer, very close to the answer. in the answer we will just change the y and we will write it x. See this. So this is the function, and this function inverse of x, that is the inverse function, will be 1 plus x. See, I'm just changing the y into x, then 3 minus this is y, so we will write x. This is how we can find out the inverse of this function. You can actually interchange in this line also if you want, then you will get directly the answer. You will get the answer. Or you can just write y equals to this, then solve the equation for x, then just at the end from this from the solution you replace it. So there is two methods to find out the inverse. Both is simple, you know. And when this value is given, then interchange them. When the graph is given, then draw a reflection about the x-axis. This is how we find the inverse. Let me check if we have anything else in this chapter. I think that's all that which is covered here in this exercise, in the whole chapter. These are the basics of the entire exercise. This is actually 5.2 in your in our book. All right, I hope it was. Thank you very much. Thank you. Oh, you haven't seen something here, so let me show you that. So I'm sorry. Oh my god. So this is the calculation here that I have done there. Okay, this is the calculation and this is the other calculation if you need. Oh, you haven't seen something in the up also. Ta-da! Oh my god, sorry. So that was the calculation, and that is what I said. Like 1 and 4, see how we found the inverse. 1 and 4, when interchange, then it becomes 4 and 1. This is how we get it. Alright, sorry for that. Thank you very much.